All right, so today we're going to talk about conditional statements. Now, this is a broad definition for all the stuff we're talking about. And then conditional statements up underneath it is going to have inverse, converse, and contrapositive. And then we're also going to get biconditional statements out of this. So all of those conditional statements, the first thing we're going to talk about, the rest of those are going to stem off of that statement. All right, so we've got our conditional statements. Conditional statement is a statement that can be written as an if-then form. What else do you guys know that gets wrote in if-then form? Come on, science folks, what's if-then? Man, I'm going to get Mr. P after you guys. Hypothesis. If we are going to heat up this water, then it is going to evaporate, right? So it's an if-then form. It's about as bad as one of my students saying a hypothesis is the longest leg of a triangle to him. I know, that rascal. Okay, you can see this written in symbolic form as P, then Q. Okay, and the way we would read this is P implies Q. If P happens, then Q happens. If P, then Q. P implies Q. So the hypothesis, look at that word coming right back, is the first part of our conditional statement, and it's the phrase that immediately follows the word if. Okay, it's going to immediately follow the word if, and then our conclusion is the phrase that immediately follows. What do you think? If hypothesis follows the if, conclusion is going to follow the then. Absolutely. So that's the fundamental breakdown of our conditional statement. It's an if-then statement. The first part is our hypothesis. The second part is our conclusion. So let's look at a couple of examples and see if it'll help us reconnect these pieces. So number one, if you live in Nashville, then you live in Tennessee. Okay, is that a true statement? Yeah. What do you mean? You don't know where Nashville is? Oh, Peter, it's the capital of country music. It's got those stinky Titans, though. But it is what it is. So our hypothesis is going to be the first part. It does not include the word if, only what comes after it. So it says, you live in Nashville is our hypothesis, which means our conclusion is you live in Tennessee. So when we write down our hypothesis, when we write down our conclusion, we're not going to include the word if, we're not going to include the word then. So our hypothesis, you live in Nashville. Our conclusion, you live in Tennessee. Did I spell Tennessee right? Maybe. Let's look at our next one. The sum, if the sum of our measures of two angles is 90 degrees, then they are complementary angles. What is our hypothesis? What do y'all have for hypothesis? The sum of whoa, where did that big old fat thing come from? The sum of the measure. You guys didn't know you'd be writing this much in geometry, did you? Of two angles is 90 degrees, okay? Again, we don't use the word if. So if that's our hypothesis, what is our conclusion? They are complementary angles. Okay. Our hypothesis, they are complementary angles. That's our conclusions. Our hypothesis. The sum of two angles is 90. Okay. In our last example, they give us, if a quadrilateral is a square, then it has 4 right angles. So if a quadrilateral is a square is our hypothesis. It has 4 right angles is our conclusion. A quad is a square. And our conclusion would be it has 4 right angles. And as we go through geometry, you guys are actually going to learn this piece right here. When we start talking about special quadrilaterals. I know that makes y'all excited. What's a right angle? Measures 90 degrees. Okay. So now, instead of giving us the hypothesis or giving us the conditional statement, they're going to give us just a general statement, and we're going to write it in if-then form. So an obtuse angle has a measure greater than 90. An obtuse angle has a measure greater than 90. So remember, we're going to write this in if-then form. And we're just going to keep the same order that they give us to in the statement. So if an angle is obtuse, if an angle is obtuse, then what do you think? Then it has a measure greater than 90. Absolutely. So this is where I was talking about on the first day, where there's not going to be exact one answer that fits everything. But at least needs to be in the framework. So Sean and Ethan both had an answer that were different, but they were both correct. All numbers divisible by 4 are also divisible by 2. What do we think? What do we think? If then form.
If all numbers are divisible by 4, then they are also divisible by 2.
Okay. So if a number is divisible by 4, is that what you said? Did that meet the hypothesis? All numbers divisible by 4? If a number is divisible by 4, then what? Then it is also divisible by 2. Fantastic. States on the East Coast border the Atlantic Ocean. What you got left side of the room? Y'all sleeping on me over there. States on the East Coast border the Atlantic Ocean. If a state is on the East Coast, let me just get that part. If a state is on the East Coast, that takes care of my hypothesis. Then, what was it?
Then the border is in the Atlantic Ocean.
Then it borders the Atlantic Ocean, yep. If a state is on the East Coast, then it borders the Atlantic Ocean. Notice that all these have been true statements. Keep track of that for later. Little foreshadowing in math class. Ba-ba-bam. Valentine's Day is in February. If it's Valentine's Day, then what? It is February.
There is Valentine's Day.
You said if there is Valentine's Day, then it would be February. I don't mind it. But like you're saying there couldn't be a Valentine's Day, right? Yeah, it's not bad. If it's Valentine's Day, then it is February. Lastly, prime numbers only have 2 factors, 1 and itself. What do you think? Left side, come on with me. Come on, take a ride with me. With the windows down doing geometry.
Oh, I see what you did there.
Yep, must be the money. That's why I'm here. If a number is prime, then what? If a number's prime, then what? It only has 2 factors. One and itself. My little and sign looks like Batman. Or a broken dove. All right, so those are our conditional statements. These statements are the skeleton, the shell of our next 4 statements. Oh, yeah. So here we go. So we've got our inverse, our converse, and our contrapositive. To find the inverse, we are going to negate the hypothesis, and conclusion. And when we say negate, we're going to insert the word not. Because what was negating in our last couple units? What did we do when we negated something? Basically, we multiplied by -1, right? When we use the word not, we're basically multiplying the word by -1 because we're doing the exact opposite. If I said, Will, do not stand up, and he sits down, he's doing the opposite. But if I said, Will, stand up, he would stand up. Okay? So in symbolic form, it's pretty cool because it's always P's and Q's. And this is my rap stage name. Squiggly P implies squiggly Q. Squiggly P, then, so if not P, then not Q. So squiggly P and squiggly Q. If not P, then not Q. Our converse, again, this all goes back to our conditional statement. We're going to switch our hypothesis and conclusion. We're switching our hypothesis and conclusion. So now it's going to go Q implies P. So now our thing reads, if Q, then P. The squiggly line is the negation, yep. And then our last one, the contrapositive, we're going to negate and switch our hypothesis and conclusion. The converse doesn't, the inverse doesn't get switched, it just gets negated. The converse just gets switched, and we're going to flip our negate and switch the contrapositive. So our contrapositive is the negation of the converse. Negation of our converse. What do y'all think for symbols? Any guesses? Oh my gosh. Squiggly Q. I don't know what letter I just tried to write, but that wasn't a Q. Squiggly Q, then squiggly P. So if not Q, then not P. You guys are like, there is too much words going on in math class right now. So we've got our conditional statement, and stem from that is our inverse, converse, and contrapositive. So we're going to write the inverse, converse, and contrapositive and determine the truth value. And if false, we're going to provide a conditional statement. So truth value, we're just going to say, is this a true statement or is it not? And if it's not, we have got to say why. We have got to give an example about why, and that's our counterexample. So we've got to justify why we say it's not true. So if it is Saturday, then there is no school. Okay? So the inverse. So let's highlight our original hypothesis. It is Saturday. And our original conclusion. So our P right? Our P, what's our hypothesis in this conditional statement? It is Saturday. Would it help if I don't have the other. And then our Q is what? There is no school. So our hypothesis is it is Saturday. Our conclusion, there is no school. Is our conditional statement true? If it's Saturday, there's no school. Is that a true statement? All right. So you ready? So the inverse, we're going to negate both. How would I say it is Saturday, and how would I negate it? It is not Saturday. So if it is not Saturday, what would be an example of not Saturday? Monday, okay. And then I'm going to negate my conclusion, there is no school. How would I negate that? How would I say the opposite of that? There is school. If it is not Saturday, then there is school. Okay, so this is the inverse of our conditional statement. Is this statement factually true? Does it have a truth value of yes? Yes, why? Why is the statement we just created true? What do you think? Today is not Saturday, then there is school. Is that 100% true? Yes, in the U.S. No, Sunday. Shaking our head, no. Yes, why? This is us. Well, how about this say us? At our school.
Yeah, but you're not saying which day it is.
So because I'm not specifically saying which day it is, can I assume it's not Sunday? True or false? What do you think? True? False? We got a lot of abstaining votes. It is false. And then what would be our counterexample? What proves this statement wrong? If it is not Saturday, then there is school. Sunday. Sunday is a day where it's not Saturday and we still don't have school. Speaking of Sunday school, it's sad that most churches have gotten rid of it almost. Yeah. We don't have Sunday school at mine anymore. I mean, and it was even before the COVID thing. I don't know. We just have main service and roll. I know. I mean, think about how cool it was learning about John the Baptist and all that jazz in Sunday school. All right. Learning all kinds of fun songs. Jesus loves me, this I know, or the Bible tells me so. Yeah. Father Abraham and his many sons. Yeah. Converse. So we're going to take our original conditional statement and we're going to switch it. So now our conclusion is going to become our hypothesis, and our hypothesis becomes our conclusion. So if it is Saturday, then there is no school. We're going to take the green one. It's going to come first. So if there is no school, somebody just fell off a chair. If there is no school, then it is Saturday. Is that statement true or false? Yes. But it didn't, so it is false. And because we just can't say something's not true, why is it not true? Sunday. Sunday, Sunday, Sunday. All right, and our last one, the contrapositive, we're going to negate the converse. We're going to switch them and negate both. So, if there is school, good. If there is school, then it is not Saturday. Is that a true statement? If there is school, it is not Saturday. Yes. Unless you get in trouble and get to spend Saturday school with Coach O picking weeds. Oh, yeah. Oh, yeah. When I get Saturday school, they don't like it. We go down to the baseball and softball field, clean out drains, pick weeds out of the warning track, carry buckets of dirt from one field to the other. It's a little bit of workout. Pressure wash. Yes, why? Well, if there is school, will it happen on Sunday? No. So it's still true. It has a truth value of true. If there is school, correct. It's just saying if there is school, like we're in school today, is it Saturday? So it's not Saturday. What about tomorrow? Exactly. All right. If the product of two numbers is odd, then both numbers must be odd. What do you mean no? Product. What's product? You're not stupid. Product's multiplication, right? So let's just say 3 times 3 is 9. So that'd be an odd product. Both products were odd. What about 2 times 3? 6. Is that an odd product? No. So yeah, so that's fine. But what about, what would be, 21? 21's an odd product. How do we get there? 7 times 3? Are both of my numbers that were multiplied odd? Yeah. Anybody else want to try one? 19 and, well, 19 is not a product. Let's say 105. What makes 105? Well, it's got to be 5. And what? How many nickels in a dollar? Nickels in a dollar. 20. So what's one more nickel? 21. Come on, guys. Think about money. All right. So if the product of two numbers is odd, nickels. You don't know what a nickel is, son? I mean, if you think about pennies, nickels, dimes, and quarters, that's how you learned how to count, wasn't it? No? Oh. Back in my day, we talked about money in clocks constantly. All right, so what would we did a couple examples to see, tested our hypothesis. Conclusion, we've got our hypothesis. write our inverse now. Remember, our inverse, we're going to negate both. What do you got? If. Product of two numbers is not odd. Not odd. We want to negate it. So we really want to stay consistent with that not. We're changing the hypothesis. If the product of two numbers is not odd, then what? Yeah, then both numbers be. If the product of two numbers is not odd, then both numbers must not be odd. Is that true or false? True. That is true. Because if they're not odd, one of them's even. And we already saw what happened when you multiplied an odd and an even number. It made a what? Even. Converse. We're going to switch P and Q. We're going to put our conclusion first and our hypothesis second. The converse. If both numbers are odd, then the product is. You nailed it, dude. I mean, because we got the two numbers in the first part, we're good. True or false? True. Okay, and then our last one, we're going to negate the converse. Negate the converse. So look right above it. We're just going to put the word not in there. If both numbers are not odd, then what? Then their product is not odd. Is that true or is that false? You didn't sound too confident. If both numbers are not odd, then their product is not odd. False. Why? Give me an example. I need a counterexample. I can't just have because. Yeah. I don't know where they are. Oh, they're right up front on the desk. It is true. You knew it. You weren't confident in it, but you knew it. All right, last one. If the temperature is 25 degrees, then it is below freezing. If the temperature is 25 degrees, it is below freezing. Is that true? Yeah. What's the freezing temp? 30. Oh, Mr. P would not be happy with you guys. 32 degrees. Thank you, Will. I heard like 36 and 30 and,
32.
oh. All right. So we're going to negate both with the inverse. If the temperature is, what do you think? How would I negate it? Is not 25 degrees Fahrenheit. Then it is not below freezing. Come on now. If the temperature is not 25 degrees, then it is not below freezing. True or false? Why? Yeah, it could be 20 or 26. Okay, good. Converse. We're going to switch our hypothesis and conclusion. If it is below freezing, then what? If it is below freezing, then no, it's a statement, so it's not a question. Then it is right. Then the temperature is (25 degrees Fahrenheit). True or false? Why? Yeah, it could be 5 degrees Fahrenheit outside. Is that still below freezing? Yep. Okay, our last one, the contrapositive. If it is not below freezing, oh, whoops, sorry. So we're going to negate the converse. So I already said the answer to the first part. If it is not below freezing, my letters are just disappearing. If it is not below freezing, remember the negation, we just throw the word not in there, then what? Then the temperature is not 5 degrees Fahrenheit. Is that true? It's a tricky one. If it's not below freezing, then it's not 25 degrees. True. Why? Because 25 degrees is below freezing, my man. I want you guys to take a peek at the first one we did and the last one we just did. What are some consistencies y'all recognize between conditional statements, contrapositives, inverses, and converses?
So, when the negative,
So the inverse.
the
What?
inverse,
Uh-huh.
the contrapositive
Okay.
always be the true statement. Or,
Not necessarily. What do you got? I like that, yeah. But let's look at the truth value. That is 100% right. Look at the truth value between our three. Is there any consistencies that we can see with our naked eye? What's that? Okay, so the first and the last, the contrapositive or the conditional statement was true. The inverse and converse were false, and the contrapositive was true. Same thing here. The conditional statement was true. Inverse and converse were false. Contrapositive was true. The conditional statement, I'm going to label it as the CS. This is just a little, this will be a test question. By the way, the conditional statement, the CS, and the contrapositive, I'm going to say CP, with truth value. And the same way, if the conditional statement and the contrapositive will always have the same truth value, the inverse and the converse will always have the same truth value. That is a test question. I mean, I can't put it any more clear than that. It even talks about a car. I'll even say that. It's even on the review and kids still miss it. Drives me bonkers. So the conditional statement and the contrapositive will always have the same truth value. The inverse and the converse will always have the same truth value. So those guys are linked together. Yeah. All right, and the last thing we're going to talk about, I'll let y'all finish writing that. The question's about a car. Saying that, say, Aiden gets his license, then Aiden gets a car. But if Aiden does not get a license, get his car, then he does not get a license. That one. Yeah. I might even put Aiden in there just for fun. All right, and our last one is called a biconditional statement. Okay, the biconditional statement. We're going to take our conditional statement and our converse, and we're going to put them together with an if and only if conjunction. So the definition is, it's a conjunction. Conjunction, junction, what's your function? Did you guys have Schoolhouse Rock? It's a conjunction of conditional statement What's that? The condition of the conditional statement. Yeah, all right. And the converse. I'm going to show you. Buckle up, buckaroo. Okay? And I will oftentimes, and so in symbolic form, it's, this little guy right here should be a U, a little upside down N. Go ahead and change that. I just think the font wouldn't allow him to put a upside down U. So in symbolic form, you've got P implies Q, and Q implies P. So instead of having to write that out every time, our shorthand is going to be P with a double arrow to Q. So P implies Q, Q implies P. P can't live without Q, Q can't live without P. They must be true. And we read that as P if and only if Q. And you'll oftentimes see if and only if shorthand as if. This if. Biconditionals are true when both the converse and conditional are true. Both our conditional statement and its converse are both true. So you cannot have a biconditional statement with one of those being false. Conditional statement. Sorry. So they're going to give us a biconditional statement. We're going to write the conditional and the converse and then determine the truth value of our biconditional, whether it's true or false. Okay. Oh, Peter. So we've got two angles are supplementary. And our other one is, oh, whoops. That's supposed to be yellow in it. My bad, yo. Two angles are supplementary if and only if the sum of their measures is 180. So we're going to take our biconditional statement and we're going to put it back to a conditional and its converse. So what would our conditional statement be? Remember, our yellow is our hypothesis, our green is our conclusion. So it always starts with if. Two angles are, what do you think? Supplementary. Then the sum of their measure is 180. Is that a true statement? If two angles are supplementary, then their sum is 180. Yes, that's a true statement. If it was false, we wouldn't even have to write the converse. Why? They both got to be true, right? So if it's false, I can just stop, honestly. Converse. Remember, we're just going to switch them. So now, if the sum of two angles is 180 degrees, then what? They are supplementary, yes, sir. Is that a true statement? If the sum of two angles is 180, then they are supplementary. Is that true or false? It's true. So is our biconditional statement true? Yeah, it is, because why? Both our conditional and converse are what? Are true. All right, last one. I know this is a lot. This is 2 lessons crammed into one. Yeah, I had to find a ways to make up days when we went down to 4. This is one of the ways. I wear my snow boots if and only if it snows. I wear my snow boots if and only if it snows. If I wear my snow boots, then it snowed. Oh, Peter, can't write in highlighter, dummy. Yeah, but you can't read it. If I wear what was it? Then okay. What would the converse of that be? Conclusion first. If it snows, then I wear my snow boots. Okay. So you say that one's true. Is the one above it true? That one's kind of whack. What do you mean? If I wear my snow boots, then it snows. You could wear your snow boots and it could not snow. We canceled school last year and it didn't even snow. We did. Well, it was supposed to snow. So the truth value is false because our conditional is false. They both have to be true for your biconditional to even exist. Yep. All right. You guys can work on the next 2, and I'll unlock your My Math lab so you can start your homeworks. Oh, no. Sorry, Hannah.